All right, the next and last thing we have to do for trig is be able to find angles. So for example, I'm going to give you a triangle with two side lengths, and you're going to have to find the angle in the problem, the reference angle, which would be either angle A or angle C. So the first thing we need to talk about is how can we find the angle? So what I'm showing you here is that the sine of A, I want to find this angle in the problem. 0.87 is the ratio. So remember, back to our old chart, if the sine of 0.87 would here, we know it would be around 61 degrees. Well, we're not going to use this old school chart, so what we're going to use is a calculator. And if you'll see on a calculator, there's the sine, cosine, and tangent button, but right above them is the sine inverse, cosine inverse, and tangent inverse. So since it's saying the sine of A, we're going to hit second the sine key. You'll see a -1 comes up, which stands for the inverse, and we're just going to type 0.87, close, and enter 60.4. So that's exact. So the measure of angle A is whatever we just said in the calculator, 60.5, let's say. So as you can see, the chart can't get as close, but we know our calculators can. So cosine of B, remember it's the angle that we're missing. This is telling you that the ratio of sides, and since it's cosine, it would be adjacent over the hypotenuse, that the ratio of sides is 0.15. So I go to my calculator, second cosine 0.15, I close it and I enter 81.4. So the measure of angle B equals 81.4 degrees. Things to keep in mind, if it is cosine or sine, the ratios have to be less than 1. Only in a tangent function can the ratio be larger than 1. And we just want to make sure we watch that because people will get an error in their calculator and think the calculator's wrong. It's you inputting it wrong. So in my first example, if I want to find the measure of angle A, I'm going to call it theta, or you can use a variable, okay? But a lot of times we refer to an angle as theta. So I'm going to do that. So here, angle A, this is your reference angle. Now you have to figure out what I give you. So I give you opposite, I give you adjacent. The hypotenuse is not in the problem. So which trig function? Oh, we totally should have TOA on our page. Sorry, I forgot that should be number 1. So if we have opposite and adjacent, O and A, I know it's the tangent. The angle always goes with the trig function. So we're looking for the angle. It's opposite over this, so 16/20. If you were quick enough, you don't have to, but if you knew that was 4/5, you could do that. Or we can make it a decimal, and we could even write tan of theta is 0.8. Either, it does not matter. All we're going to do is now go to a calculator, hit second tangent. I'm going to put 4/5. I'm probably not going to do, you could have done second tan, you could have done, sorry, back, 16/20. You don't even have to simplify. So it's 38.7. Okay. You can use a variable. We just tend to use theta when you're talking about an angle measure. But if you used x, that's fine too. All right. Let's try one more, 2 more. Okay, let's look at this one. I want to find the measure of angle A. So this one, just so you see, I'm going to put a variable x. So from your reference angle, you have to decide what you have. I have opposite and the hypotenuse. So I go again. Remember, I want to have this nearby. I don't want to have to look for it. So TOA. And I know that I have opposite and the hypotenuse. If I have hypotenuse, it has to be sine or cosine. Here, sine of x equals 15/25. You don't have to simplify. You can literally just put second sine 15/25. Second sine 15 divided by 25, enter, 36.9. Again, if you are getting or picking up a new calculator mode, it has to be in degree, and that's either on Desmos or on your regular calculator or on the calculators on my table. So any of them have to be in degrees. If they're not, you're going to get a much different number. Okay. All right. One more. Please try this on your own. Decide which trig function you're going to use. If that is the angle we're trying to find, which trig function will you use? Hopefully you realize this is adjacent and the hypotenuse. And so then if I go back to TOA, it's going to be your cosine function. Angle always goes next to the trig function, and it's 18 over 24. If you are somebody who likes decimals, you could see that it's 18 divided by 24. The only problem with this is you don't want to ever round this. So that's why I really don't like that method. I literally just want you to put in 18 over 24. Second, the cosine inverse, 18 divided by 24, enter. If you're not getting these, your calculator's not in the right degrees. So theta equals 41.4 degrees. We'll go down to the bottom of the note sheet and it says something like solve the right triangle. When I ask you to solve this, all I want is every angle on every side in the problem. So as you can see, I know this is 90, that's 65, I know that's 10. I don't care which way you decide to do it, which way you go first. All I want is the other values. So I want what NP is, I want what QN is, and I also want the measure of angle N. Okay, so pause the video, see if you can find them. All right, for angle N, I'm going to use 180 minus, well, I'm going to use 90 minus 65. So I already know this is 25 degrees. So that's easy in this problem. In this problem, it wants side length. So you can call either one of them X or Y. I'm going to start with this one. I like to do one at a time. You have an option. If you have two reference angles, you could use 65 and do opposite and adjacent, or you can use 25 now and do opposite over adjacent. There's no hypotenuse. So I know it's the tangent function. I'm going to do 65. At that point, I know I have opposite and adjacent, no hypotenuse. That's why I chose tangent. Opposite X, adjacent 10. In this one, when I actually have to solve, I'm going to put it over 1, cross multiply tan of 65 times 10, and I'm going to put that in a calculator. Remember, not the inverse key. Tan of 65, I close it, times 10, 21.4. So now I know this is 21.4. So I know this side's 21.4. Now, you can use trig, or you could simply use Pythagorean theorem because now you have a squared, b squared. I'm going to use trig, so I'm just going to do tan of, not tan, because now I want the hypotenuse. I'm going to call that y. So I'm going to use the 10, which is adjacent, and the hypotenuse. So if I'm using adjacent, that's cosine of 65, adjacent 10 over y. So then I'm going to cross multiply. I'm going to get 10 equals cosine of 65 times y. That is where I have to divide by the cosine of 65. So they're switching. So y equals, in a calculator, 10 divided by cosine of 65. 23.7. So 23.7. Should that be my longest? Yes, it's my hypotenuse. Everything in the problem makes sense. So when we're solving, this is another one. If you would like to go and try this one to make sure you're good, pause the video, do it, and I'll give you the answers. Things to remember. It's the second key when finding angles, okay? So you want that on your paper. You need to use the second key if you're looking for an angle, or if you're more a math person, the inverse key, Okay, and that's second sine, second cosine, or second tangent. Go ahead, pause the video, see if you can solve it, and then I'll write the answers. I want to find an angle since I don't have any. I'm going to put the angle here. I just picked this. You could have done D or F. That's adjacent and hypotenuse. So it's cosine of theta is 3/9. That's the second cosine, 3 divided by 9, or 1/3, 70.5. So now I know this angle is 70.5. 90 minus 70.5 is 19.5 degrees. Now, I'm going to use 3 squared, x squared, and 9 squared to figure out Pythagorean theorem. 81. That's what I did. I'm not going to use trig. 8x squared equals 72. Square root of 72. Now, if we're using decimals, because in trig we normally do, it would be 8.5. Otherwise, we would break it down into this. So it's 6√2 or 8.5. I'll take either one. Okay. Good job. Thanks.